Hello everybody. Now we can start with the new lecture about Elasticstack and logging particularly. So I want to focus in this lecture mostly on logging because usually logging is confused with monitoring, but we're gonna have a separate lecture for monitoring. So first we will talk about logs and how logs work inside your infrastructure. And for this purpose, I chose to teach about Elasticstack because there's other tools you can use, a lot of different things. I'm not going to restrict your wish to use anything you will, because probably some of you might work in a company already and you already have preconditions to use particular tools that your boss is requiring. But in any case, I want to show that doesn't matter the tool you're using, it's about the paradigm you apply. So it's not just about learning a lot of tools and just trying them out and you go through them and that's it. That's not the way things should be done. It's always better to get like a couple of tools and learn them very well. Of course, you need to make a choice because some of the tools are not gonna get maintained. Sometimes you're gonna have to make your own tools, but in general you have to get around it in detail and to understand what it does in order to be successful in what you're gonna do with that tool. And this applies for everything, not just Elasticstack or what we learned before. So it doesn't matter. Like to install Elasticstack, I think I will give some good options with the lecture that I will post for Ansible automation. And there we're gonna provision Elasticstack automatically, but in this case we're gonna focus what you need to do with Elasticstack, what you're gonna do exactly, what kind of data you're gonna collect, and whether you're gonna do some monitoring together with log collection, etc. So here we need to understand what to do with Elasticstack after you install it. The installation is very simple, it's straightforward. You don't need to use Ansible or Puppet to install anything similar. You just need a couple of commands and that's it, you're up and running. So we can start. I want to introduce what this contains. So this class is gonna focus mostly around Elasticstack that's comprised of the Elasticsearch Logstash Kibana and of newly they have introduced beats a couple of years ago. I will get to that thing. So for now, I would like to remove myself from the screen because I don't think I want to take any space around here, so you can see at least better. So first of all, what is Elasticsearch, what is Logstash, and what are these tools? So Elasticsearch, in fact, is a database. It's more or less a search engine with a database. It's based on the Apache Lucene search engine. And we're not going to talk about in this class how search engines work. That's a data science thingy, and I can explain this in some separate lecture, but we don't need to get in details how search engines work. So that's a different topic. But that's what Elasticsearch is. It's about querying complex structures and traversing through very complex and big data. So that's where it excels at. Logstash is a log aggregator, and Logstash is actually great for collecting different types of data. For example, let's say you built your infrastructure with Puppet and you want to collect logs not from the actual infrastructure that's running, like web servers or whatever, but from Puppet itself. Because Puppet retrieves some state from the agents that are running remotely, and you want to get to know what this state contains. Like sometimes there is a problem which is not evident, and you can't know. And there is some, but you can't narrow it down, and you can't zero to the issue itself. So what you need to do is to have some system which can perform some automatic search through these things and tell you, oh, there might be a problem here. You should probably pay attention to this portion of the logs. Something is going on here. So this is where alerting comes in. That's where things are different from monitoring. Monitoring is more like you're collecting some particular data and metrics, and you use this data for some purpose, either for just getting to know that the temperature, let's say, in your data center is not exceeding the normal or something similar. So that's the difference. For example, let's say I want to use analogy to make this more clear for you, because sometimes it's confusing and some of you are confusing the difference between logging and monitoring. Logging is a way of monitoring, but in this case, you're collecting literally logs. And what are logs? So for example, you go to the doctor and the doctor can, let's say you have a heart condition or whatever, and the doctor will tell you, okay, in the next 20 days, please, can you write for me what you're eating, the things that you're doing at home, how much you exercise, where you go, what kind of stuff you drink, how much coffee, how many cigarettes, all of these things. So you need to keep a log. So that's logging. You need to provide the doctor, a rough picture about your general state, what you're doing, because if he's just collecting, let's say, information from your white blood cells, from the blood that he pulls, I'm not sure he's gonna get much from that, because he can, narrow it down by knowing whether that's attributed to your lifestyle or it's, increased number of neutrophil cells or whatever, so you can have some sort of infection or it's a cancer or something. So that's how these things work as well. If you want to narrow down the issue, you need to combine these things. So monitoring goes together with logging, and all of these things work together like in an orchestra. So if you really want to make this work properly, we're going to go through all these things and you're going to understand what everything is so you can use it in your advantage. Then, last but not least, you would like to visualize all of this, and there's Kibana for that. It's a visualization layer, and it's integrated tightly with Elasticsearch and Logstash. And then you can have really some fancy stuff happening on your screen. It's not like the Ansible CMDB we had, just some plain HTML stuff. No, this is very nice. You will see. I will show you how to install all these things and how to collect some data. Last but not least, there is Beats. Beats is another component from this stack, which is literally a lightweight shipper of data. So it's a collector that you can integrate with different plugins. Like, for example, you have different types of beats, like metric beats, packet beat. The packet beat collects, network information on layer 3, or, layer 2 if you want to collect VLAN information, stuff like that. Metric beat collects metrics from your servers, like temperature of the CPU, of the GPU, etc. And you have different, filters you can apply here, and it's a pluggable architecture. You can use, let's say, Wireshark together with, this is something I'm doing. I'm using beats with Wireshark together to create some specific filters for a PDCP layer in 5G networks. So we can collect, information about the control plane in the 5G networks, because every network has control plane and, user plane, where the data is traversing towards the users, and control plane for, control purposes of the network. So you can dissect this, and you can, have a correlative type of investigation inside the network to see whether there's some cyber attack ongoing or there is some additional problem, etc. So there's a lot of reasons why you want to use these things. It's not just forget about it and let's fix the problem when it comes. Sometimes you want to dodge the bullet and avoid the problem before it arises, and that's why you can use anomaly detection and some advanced machine learning features, etc. So this is where these things are becoming very popular nowadays. And if you're up to get some knowledge in machine learning, I think you will get to use these tools pretty much a lot, because you're gonna collect a lot of data from specific places. So why is this popular? As I said, monitoring is a thing that you need to understand as a general part of your management solution in the place where you work, or at home, or if you have your own cloud running, wherever it is. You want to monitor stuff. Without monitoring over time, we can't deduce whether the problem is something that's just a random occurrence, or I don't know, electricity voltage change in the moment or something. We need to know for certain whether there is a problem transpiring. And this is how you can do that. You can, collect data over time, and you can process that in a different way. You can filter it, you can analyze, you can draw diagrams and plot graphs, etc. So that's a normal way of doing stuff. Now, you will see that the Elastic Stack is gaining a lot of traction within the industry, And yes, there is an enterprise level of Elasticstack, but Elk-Stack is an open source thing, so it doesn't matter if you don't get any support from the companies related to these operations. If you know the tools very well, you can do everything by yourself. Like another way, for example, is to use Splunk. Splunk is a very, very popular platform also for data collection and aggregation. So I'm not gonna get into Splunk. That's a different topic, because here we need to focus on logging explicitly. For monitoring, we're gonna have a different lecture. So why do we do logging? Like, as I said before, computers speak to you. They have a way of expressing their pain and their state. So they tell you all of this, but the difference is whether you listen or not. So sometimes if you have, you know, a lot of computers and they all speak to you at the same time, you can't listen because it's a lot of information and you need some help. And this is exactly the help that you're getting. So to make something, let's say, in a high availability environment, you need, for example, dynamic scaling of stuff. You need to scale your infrastructure in a continuous manner. You don't want, you know, to end up in a state where things just fall apart and you log in and you start fixing and all of this. You know, it doesn't work anymore like that. Nowadays we have complex tools for this purpose, and this is exactly where log analysis can help you. You can take information from your infrastructure and use this for your provisioners. Like, I don't know, we thought about Terraform and Ansible, or you can use Puppet, or you can use Kubernetes as well. Kubernetes has its own little interesting system. It's called Horizontal Pod Autoscaler. I will talk about that in the upcoming lectures about microservices. And you can use data, pull data from your web servers, for example, HTTP traffic or CPU usage, or different parameters, whatever you decide to use, in order to dynamically scale. And this is, for example, for the sake of avoiding DDoS attacks, or, you know, to make a better quality of experience for the end users, etc. There's a lot of reasons why you want to do that. Making something monolithic and simple, it's not gonna guarantee you very well that your infrastructure is going to be stable and everything's going to, you know, keep to the normal. Otherwise, you want to have something like this. So logs are something that existed all the time. I mean, you know, if you check the logs manually from the Linux or from Windows, you will find a lot of information, because the computers are reporting from the processes and the services running in the background from different namespace. You know, everything is aggregated, everything is cluttered. You can go through the logs and you can manually check, you know, sometimes that, I don't know, your web server is not running, something, it doesn't want to start. And then you go to journal.ctl or something and you check the logs, and you find out that it's not running because you missed a semicolon in the configuration file. So this is something that you really need, because you can't know what's the real problem behind the actual service that's keeping itself down. And why we say it's centralized logging? Because all the logs are kept in one place. You need to have just a single point where you need to refer to, like a server or something like this Elasticstack we're going to talk about. And this is where you're going to perform the analytics, you're going to perform the aggregation of logs, you're going to perform, any kind of operation just to make your life easier. This is not to make everything complicated. It's a great practice to make your life much easier than it already is. So there's a couple of ways you can manage logs. And for example, first is you aggregate logs. That's the ability to collect and ship logs from different data sources. Talking about this, as of yesterday, 10th of March 2021, Elasticsearch is officially integrating with Grafana. We're going to talk about Grafana and Prometheus, because these two are like one thing. They integrate very tightly, and you can use the Grafana to plot a lot of nice and very beautiful dashboards from Prometheus monitoring system. So this is, very standard and great practice, very standard way of doing stuff. But now Grafana integrates with Elasticsearch. So people ask why Grafana when we have Kibana. Well, this is exactly the aggregation. If you have different data sources, Kibana works only with particular data sources, and it's specially, tailored for use with the Elasticstack. But Grafana is a generalized dashboard. It works with various sources. You can use Grafana with InfluxDB, for example, and time series databases to stream real-time information, and just for the sake of real-time monitoring, you can have analytics, with machine learning. You can have a lot of things with Grafana. So this is something that's I'm looking forward to try, and I can perhaps make a nice example for you so you can test this by yourselves. I'm not gonna make this very, very complicated, because Elasticstack can be super complex architecture, but we're gonna try, with one server, and we're gonna run some database or a web server, and we're gonna collect some information from this, we're gonna make some traffic, etc. So you can see what kind of things you can collect. Then processing. Processing is the ability to collect all this clutter and make use of it, because if you just saturate your, let's say, machine learning algorithm with a lot of data, of course, we need a lot of data for machine learning systems to get some meaningful output. Like deep neural networks, they work on the basis of getting fresh data constantly. But at the same time, more information doesn't mean better. You can create more bias that way. So this bias is also very common between humans. If you get a lot of information, you can draw very wrong conclusions sometimes. So bias increases the moment you start, cluttering your system with a lot of data. So you really need to filter out the unnecessary stuff and just keep the things that you need. And this is where the processing part comes. Then the storage part, what I mentioned, if you use a time series database, you don't really need to worry much about storage, because time series databases are non-relational, and they don't really need to store keys and values, stuff like this for your users or anything. It's just, CSV type of information, like a tabular. It just flows. It says, oh, for temperature we have in the next second, you put a hysteresis every second or every 2-second refresh rate, and you're getting the temperature ongoing on your GPU while it's running some workloads, or while you're playing a game at least, or something like that. So all these monitoring systems, they work like that. So if you decide you want to store this information, to plot it in a graph, to store CSV or any format, that's something that you need to think about separately. And this is where the Elasticstack is coming into play. You can decide all of these things at the same time. So how you're gonna aggregate the data, to process it, to store it, and to analyze. Because if you don't do all of this at the same time, then you're gonna have to do it separately, and that's gonna be very cumbersome. So how do you use the Elasticstack for log analysis? So when you put everything together, it starts making perfect sense, because Elasticsearch is the actual key component here. This is where the workhorse is. Logstash, beats, these are collectors and aggregators, and Kibana is, visualization tool for analysis. But for storage and the processing part, this is where Elasticsearch is doing the things. So this is, for example, on the picture, you can see a classical deployment. We're gonna try this on one server, so I'm not gonna make it complicated for you. You just need to understand how these things work. Then there's other ways you can do this. You can use some sort of buffer for resiliency. A good way is to use Redis or Kafka. They are very popular, especially Kafka. They have their own advantages and disadvantages, but in general, this is a standard way of doing stuff when you're handling cloud infrastructures, for example, because there's immense amount of data flowing through clouds, especially if we talk about, public infrastructures and something similar. Then you need RabbitMQ, for example. RabbitMQ is a queuing system So you need, to have some sort of ticketing so things can come in time. Otherwise, if a lot of information from the beats the collector sends to Elasticsearch, it's just gonna create a mess. You need to have some, some sort of temporary storage of this data before it can get aggregated by Logstash to say, okay, this is logs for, I don't know, Puppet, these are logs for Ansible, these are logs from Kubernetes, these are logs from the Nginx web server or from the load balancer. So you can keep a lot of logs, and in the end, it's a mess if you don't have a way how to separate this into different categories. So a way to make Logstash do this in time without problems, and I'll show you later, there's a lot of problems because Logstash has shown to be a little bit of a problematic tool, unlike the rest. But despite of that, it's still being maintained and it still works. But you need to get some, hand grip on it before it can do the things the way you want. In any case, if you want Logstash to do the job properly, you need to get the data to it in a reasonable manner. If you just throw everything at it, it's just gonna break. So this is simple, and in production, in reality, you can have, for example, clusters of monitoring and log collection architecture systems. So these clusters usually need some sort of service discovery, like etcd, or you need, as I mentioned, RabbitMQ. You need additional tools to keep things in line. You can just, install Elasticstack in one VM, and the rest, it's gonna just throw the data to that VM. Everything's gonna work. It doesn't really work like that. You need to have high availability, and for high availability, you need to have some sort of dynamic way of thinking, not just static deployment and that's it. You need to understand that your infrastructure can move also somewhere, like if you're working with like AWS, like multi-region clouds, or we have, for the matter of fact, we have only one region of the cloud here, but in any case, if you're working with multiple different regions, then your infrastructure can move. Depends on your, let's say you have a website somewhere, and the moment you experience more loads on your website in European cloud zone or region, and then somebody just decides that your product is very attractive in China or in United States, then your infrastructure is going to move from the European region cloud to the United States one. So people can access the website in a bit more reasonable manner, so your application doesn't fall apart. And this is done also to reduce international traffic. And yeah, so this is something, for just an example how things are done in production. Then how to install the Elasticstack. There's lots of ways you can do that, and it's very simple, to be honest. I will show you in the slides here because that doesn't really require much of an effort, but that's not the problem. That's not the problematic part. The biggest problem is how to use this, and this is where we're gonna focus in the next video lecture. You can deploy Elasticstack locally or in a cloud, or as we did with the case when we deployed hybrid infrastructure using Ansible. You can deploy the Elasticstack in an Amazon cloud. You can move it around wherever you go. And let's say you have a on-premise solution in a data center. Your company moves to, I don't know, Africa or somewhere, Australia, and you want to move your logging architecture that you created somewhere closer to your data center that you have your operations. So in that case, Amazon will move the stuff from Europe to Australia, of course. But there's also ways you can do this in containers using Docker or Kubernetes configuration management, as I mentioned, like Ansible, Puppet, or Chef. So there's countless ways you can do this. The same applies, for every monitoring system. So the installation is not such a big problem as the usage is. So to prepare for this, you don't have to use an M4 large instance, as I mentioned in the slides. You can use a smaller one. it's not gonna create any difference because you're not streaming loads of data. So you just need to use 1804 Ubuntu, and you can use a small instance, it's fine, or medium is gonna be more than fine. So yeah, it's just about the storage, because there can be a lot of information, but I'm not gonna show you how to collect literally everything, so we're just gonna demonstrate how this works, so you don't need to, you know, prepare some special environment about this. Also, you need to make sure that you set an adequate security group if you want to access from anywhere. But I would strongly suggest that you use SSH TCP tunneling, as I described in the previous video with Ansible, that you don't really need to, you know, open ports from the cloud, you know, additional cybersecurity risks, etc. We forget about these things. You can't remember what you opened, what you created sometimes in the configurations. So it's better to do this adequately in advance before we forget what we did later. So what do you need to install Elasticsearch? There's a great way to do this through the repositories, and you can get a package as well. You can add, let's say, the GPG key, and then you can install it by apt. You can get the repository as described lower here, but there's other ways you can install this. This is just one way I put here for you. This is a code that you can, you know, copy paste. You'll have the slides in the canvas, so you can use this in your advantage. So this is gonna install some version 7 point something. You can see whether there is a newer version if you want to install something later, but it doesn't really matter because we're not working with some very obsolete versions anyway, so you'll get the most updated features from the things that you see in the slides here. Next is you can just run apt update and install Elasticsearch, and that's it. So there is a YAML file, and this is, for example, a great way to practice in OpenStack. So you can create a local host on your machine and create some just initial configuration as it's shown here. We'll go through this, so don't worry. I'm not just going to leave it on a Word as you see here. This is just a rough example, so you can get a glimpse on how Elasticsearch can be configured, and then you can start the service, and that's it. But now, for example, if you want to test this, you can do the following. I think this is just a picture. You can't copy paste. I made some small mistake there, but I'm not sure it's gonna create a big difference for you. So in general, if we want to confirm if everything is working, then you can just check the browser, or you can get output like this. So you don't need to copy paste anything here. It's just an example. So if you want to learn about how to cluster this, because you don't need to stick to one machine for your knowledge, you can expand this. You can try to run the Elasticstack in like 3 VMs, like the search engine 1 VM. The beats collector can be an agent, you know, running somewhere remotely and sending data to Logstash, which is going to be to a different VM, etc. You can create this kind of clustering. And to do this, there is a great tutorial here. You can check this. There is a lot of information on the Elasticsearch website. I strongly suggest that you see the documentation, as with every other tool, because I can't cover everything in these slides. I'm just gonna go through the most important things, but there's a lot of work that you're gonna have to do by yourself. That's how all these things are, unfortunately. So I can try to show you the initial stuff, how they work, and to get you kick-started with all of this, but the majority of the job and the learning, it's something that you're gonna have to do. We've all been through that. So yes, please just take a look at the documentation, and I think that's gonna be very helpful for you. To install Logstash, you're gonna have some precondition. You're gonna have to install the Java runtime environment, so you can install 8 or 11. And I think it's gonna be pretty much enough. And then you can just apt install a Logstash. It already exists in the apt repositories, and that's it. Now, if you run it, sure, it's not gonna do anything. Before you do that, you need to configure a data pipeline. We'll get to that, but first we need to install Kibana. And Kibana installation is even simpler. You don't need any kind of precondition, just apt install, and that's it. So in this case, Kibana is gonna listen on port 5601 and the Elasticsearch URL localhost. So just please, guys, run this on your local host. Don't expose this to the floating IP. I'm showing this for the sake of demonstration if it's, you know, on a floating IP, but you should do this in your local host. And if you want to access this through your browser, you can use, again, SSH tunneling. So you can have local tunnels, remote tunnels with -L, -R option in SSH. If you don't know what that is, just ask me a question in the Discord server and I will help you with that. It's very simple. Just please let me know, because many times I don't get some questions and I don't know if you know something or not. Sometimes your questions are regarding particular errors, and this is actually where I can help you little with, because I need to know everything what you did before, and I need to know your logs and all of these things, and then maybe I can help you with the errors. But it's more important to ask the things that you don't understand, like why do we do this? Why is this like this? Or why does it have to be like that? And then we can, you know, discuss it, why these are best practices and what is not a good practice. This is very important because errors can be different anytime. We don't know what kind of errors we're gonna encounter, but it's very important to understand why we are doing what we are doing. So Kibana is very fancy. When you access the browser, you will see a lot of features like automatic collection of metrics, logging different types of metrics you want to add, and, you know, security analysis. There's endless things, and, you know, Elasticstack is growing. It's becoming a really serious player in the industries. I think it's one of the most serious ones. You will see it everywhere in very popular companies and corporations around the world. So yeah, then last we're gonna install Beats, and this is something that can be very useful. It's a very small application, but it's super useful because it makes your life very easy. And I think it's a great thing because they created this ELKB, like Elastic Logstash, Kibana, and Beats. So they still call it Elasticstack because they implemented Beats. This is a very nice small tool which will allow you to monitor your servers. So it can integrate with Prometheus, you know, it can ship data to Grafana as well. You can create a different pluggable architecture, as I said before, using Wireshark or some network monitoring. You can create anything you want, so it's beautiful. And there's a lot of filters you can apply already existing in the documentation. If you check the documentation of Beats, you will see a lot of filters. So there's a AudiBeat for Linux, you know, monitoring the Linux, and WinLogBeat for Windows. And there's a lot of stuff, you know, people work on these things, they develop new features. So Beats is gaining quite a lot of traction. And it's pretty much simple to install, as you can see. 2 commands, you can install and start it. So I have shown in the example with Ansible, if you saw that lecture, that's not a mandatory lecture for now, but it will be. So if you see that, you can check how actually installation goes with Ansible. Pretty much, we just add a apt resource inside the Ansible module Galaxy to install a metric bit, and that's it. So if you want to run it on your web server instance or wherever, you just add the metric bit, and it will. You can pass a configuration file as well, and that's pretty much it. Now, to get something done here, okay, I'm just gonna go slowly with this because it can become pretty much cumbersome because there's filters that you need to use here. I'm not gonna explain this in a very big detail now because we're gonna go in practical part for this. It's just pointless to, you know, look at the code and listen to me talking. It's not gonna have any effect. I want you to sit on the command line and do some of these things together with me, and then we're gonna understand better. I'm gonna speak and I'm gonna explain every little detail that's in the code. So this is how it looks in a configuration. You need to define some sort of input, which is a log. It can be a path, like a log file that you have from an Apache server, like Apache Daily Access, most probably access to the web server from remote locations, and this is kept in logs. Then you can start checking the log from the beginning and keep this running in the background. And then you apply filters like grok filters, and you can try to match message like combined Apache log, then timestamps when the exact things occur, the client IP where you have a GeoIP filter. This is a separate filter, date filter, grok filter. So these are filters that you can apply in Elasticsearch to get this data represented in a graph or something, or in a table. So in general, this is a very simple example. You can go very deep with this, very detailed. Then you need to start the Logstash service. So if you go in Kibana, you can define where your Logstash is located. So you can use wildcards as it's represented here, and you can define patterns, what kind of indexing patterns you want to use. So let's say if you can display the Logstash index and along with the metric bit, if you follow the steps for installing and running metric bit. So if you do that with a packet bit to monitor network, it's going to be more or less the same approach. So then when you enter the Logstash, then you can put a timestamp as your filter field. There's different filters, but you can add timestamp for following the logs in a timed manner, and this is a very, very classical approach. Then you can create, when you press create index pattern, you can analyze the data. You're gonna have a lot of information there. So if you go to the Discover tab, you can take a look at the data and what's happening, through these timestamps, because this is the exact filtering that you have entered in Logstash to show you the things that are happening in a timed manner. So that's more or less it. Now I will go in a bit more of detail about what we're gonna do with the Elastic Stack. However, you can check some links I provided in the presentation. This is a nice place where you can get some tutorials and stuff. I'm not using particularly features from these tutorials because I don't want to get too much complicated into the examples for you. You need to just understand what these things are, because later you will. It's much easier to do the things practically when you know what they do. This presentation is gonna be a bit longer, so please don't worry. You can replay this anytime in a separate instance if you watch the video. So just take your time, and I would like to talk about everything here because we don't really want to miss any detail. So what do we do now? What about after we install the Elastic Stack? What's gonna happen? Well, it's very simple actually. We just have to get the hands dirty, and that's the way things are gonna work. And that's the difficult part. So what is Elasticsearch specifically? If we dive deep into the tool. So this is the central system of the Elastic Stack, and it's one of the most popular database analysis tools that we have today. It is a database itself, but it's also a search engine. So it's released in 2010, and since then it has matured quite a lot. It's like it works similar to SQL, and but it is categorized as a NoSQL database because the way things are done in data shipping and log aggregation and monitoring using time series, you don't really work in a SQL manner when it comes to storing the data. But when it comes to querying and searching through the things, that's where you will see some similarities with SQL. But in general, I'll try not to go so much deep in this because, as I said before, it's much better if we do this in practice. Elasticsearch focuses very strictly on searching and traversing through the data It has a very extensive REST API, which makes it very, pluggable, and it works very good with the rest of the components. So it's not just Elasticsearch you're gonna need to use. That's why you have also Logstash, Kibana, and Beats. So what kind of things does Elasticsearch have? What's the things and the features it uses in order to achieve the job it's supposed to do? So first is let's say indexing. I put it as a first because I think it's a good place where to start, because indices or indexes, they are logical portions of specific documents that can be compared to a database. Like normally, like you use indexes in programming or in other stuff, it works in a very similar manner. So for example, let's say our e-commerce app that we can deploy, you can have like one index that contains all the data related to the products and another that's related to the customers. So this is how you create this relation in between each other, similar to how SQL works, but SQL uses instead, keys and, primary keys, secondary keys, etc. So that's the difference here, because indexes are temporary and you can define them the way you want on the fly. So they are identified by lowercase names, and yeah, you can use this for different purposes. If you want to make a new entry, to append something, to delete an entry, etc. Then you have documents. That's how they're called. They're not called playbooks like Ansible calls them, or it's a different concept here. So you have Elasticsearch documents. So these documents are basically JSON objects, like dictionaries, more or less. So in the example app for e-commerce, I can show later, you can have like one document per product or one document per order. So if you have, let's say, orders list, that's going to be a separate, structure. It's going to be separate document as it indicates. You can store as many as you want. There is no limit for that. Yeah, the data is defined with fields like keys and values. This is not the same like with SQL, don't confuse that, but it's similar to how Terraform works. Like as we explained with the Ansible example, Terraform creates an output, and this output is parsed into JSON file. So every output has specific, keys and values for these keys. Like for example, fixed IPv4 and value is the actual IP address, right? So to access this, you're gonna have to point towards that location. It's very simple, it's very neat, and this is also very understandable. That's why you have YAML and JSON files. So it's gonna be easy to understand for a human. You don't have to traverse through complex structures, etc. Then you have types. Elasticsearch contains types. So what are types? So types, you can divide the documents, the data inside the documents between different types. And you can, classify this and represent it as a unique class of a document. So types, they have names and mapping and are used by adding the type field. This field can be used for filtering when you query like specific data. We're gonna get to this in a practical example, but yes, after Elasticsearch version 6, the indexes, they can only have one mapping type, but after version 7, yeah, this kind of specification of types is deprecated, and after version 8, specifying types in requests is not going to be supported. It doesn't mean much to you right now, but this is something good to have to remember, because we'll see what that means later. Then mapping, as it indicates, it's like literally like a schema or template you have in the world of relational databases. The mapping defines different types that are put in an index. So you can map like a couple of different types to create a template. Like, for example, let's say you have types that define a specific product in your orders. And then you can see, based on these types, to create a mapping that people are buying mostly, I don't know, notebooks through the weekends. Stupid example, I know, but I think it makes it a little bit more clear. So it's not like SQL works with, manually assigning keys and values, but this is dynamic more or less. You can create such an environment where you can map um, by templates. So you can create this kind of templates by yourself, as I mentioned before. So yeah, something like this. And we're not gonna get so much into these details, but there is this, and you can take a look into the documentation about how these things work if you want to have some great data processing platform. Then Elasticsearch uses shards. So how can I explain this? Shards, well, as I wrote here, this is actually a good reminder of me what I need to say about it. When you have indexes which grow, because index sizes can be a common cause of crashes in Elasticsearch, there is not really limit how many documents you can store on each index. So that can become exceeding after some time of collecting data, and you're running out of disk space, etc. So to make this a bit more convenient for you, you need to split this into pieces. So you have some sort of horizontal scaling, and these splitters, I mean, these pieces are called shards. They are kind of like sub-indexes, if you will. So yeah, I think it's very hard to explain these things in words like this, but I hope I can go through all these things in examples. I'm not sure I can get through every detail, because indeed Elasticstack is a very big system, so it's gonna take long time, and we have other lectures also coming, so I don't want you to get overburdened by just one lecture in the whole course. Yeah, Elasticsearch has replicas. As every database that works with replication, you can have a couple of different copies of the same data, or store it in high availability when you have clustering. I'm not sure we're gonna manage to have an example for this, but if you want to try it yourself, please feel free to do so. And I encourage this, because this is actually a production grade way of doing stuff. So if you want to have the real feel how things are done, you deploy it in a high availability, and you'll see how replicas work. Your data gets distributed across multiple different places, different virtual machines or containers or wherever you're storing your stuff. Then now we're gonna say some words about queries. As Elasticsearch is built on the Apache Lucene engine and exposes such a query syntax, you will have a bit different querying than in SQL. It's still, there are similarities, but it's not the same. Don't mistake it that I mentioned before. You'll find similarities with SQL that is going to be the same. It's not going to be the same. Like, for example, Boolean operators, yeah, they're standard expressions you can have in query languages. Then you have fields, of course. So fields, if you want to see, yeah, this guy is done, he's finished. So I think, yeah, you can check fields by name, address, etc. I mean, you know what it means. So this is a common thing. Then you have ranges, wildcards, and regular expressions, and also fuzzy logic searching. This is something similar to machine learning, and we're not going to go that way, because this is more mathematical approach of using bias and propensity scores to search through data. So that's something that I'm not going to put so much focus right now on. It's just going to create confusion. The most common stuff that you will need are listed here, because age, if you have like from 10 to 50, price, how many people are gonna get vaccine, etc. So yeah, this is how you can use Elasticsearch to see whether you have a lot of infected in your country and you have less people vaccinated, etc. Like, I'm just giving a stupid example, so this is very common. Another thing that is very useful is universal resource identifier searches. So in this case, you can search clusters through URI, and you can pass this type of a query like in a very simple manner. So that's I think quite useful if you use this with Kubernetes. I haven't done anything similar with this, but I can assume that you can use this in a manner of deciding which resource is where in containers, etc. So you can send specific queries to specific locations. I haven't done this, so there's a lot of stuff here that you can't try everything. It's a lot of things. If you're doing your job with data structures and analytics and stuff, it's most likely that you're gonna pay more attention to all of this, and you will learn much more. But for now, we're gonna keep it simpler. Yeah, so URI doesn't support all the features by Elasticsearch. Hopefully this is gonna change. So yeah, the full potential of Elasticsearch is exposed through something called request body search. This kind of search allows you to build complex types of search structures and query, through clusters and a lot of data, etc. So I'll try to get some very nice, neat example for you to get most of these things in one place. Then you have REST APIs. You can integrate, some external plugins or whatever you have. This is very useful, for example, in our case when we work with Internet of Things and 5G, where you have some data that the IoT devices need to send. So if this is collected through, third-party application like this, it's going to be very useful for you to have an insight what's happening in such a huge environment, because when you work with IoTs, if you don't have some complex system to query through your logs and information, you're gonna get lost. It's not even a server structure of, I don't know, 1,000 servers. You're working with millions of devices, so you can imagine that complexity. And this is where things become simpler. REST API is a very, very beautiful thing. To query something, as you can see, this is the way it's done. It's very similar to how JSON work. I mean, this is JSON. So if you want to query, you just use key value structure. So if you want to search through something, you just query and match all the things that you want. And how many shards? Oh, pardon. Shards total, how many successful skipped, etc. How many hits, value of that, etc., etc., etc. So we're not gonna keep on this. It's just gonna make you more confused. But this is just an example how you can, pass a query of some sort through the REST API. Yeah, REST APIs are very nice thing. You can check more on these links I provided in the documents, because we don't have too much time to go through all of that. It's a very nice thing if you want to develop some custom environment for your applications. As I mentioned, if you're working with IoT and sensor networks and industrial systems, etc., this can be very, very useful. So make sure you give it a look. So you have different of APIs. You can see that we listed a couple of the most important ones, like document APIs, search API, indices API, cluster API. So that's like the standard of Elasticsearch. Then Elasticsearch also supports plugins that you can extend the functionality of the application, and these plugins are divided into core plugins or community plugins. I haven't personally used much of this, so you can check. This is also a link that leads to the Elasticsearch website. And yeah, that's similar. Like we worked with Ansible, you can extend anything you need using plugins. This is a very nice thing. Pluggable infrastructure is a lifesaver. Imagine you have to write all these things by yourself. It's gonna take you eternity to deploy some working architecture. There's different types of plugins for Elasticsearch. So you have like, as we mentioned, API extension plugins. You have alerting plugins. This is very, very good. You can create, email alerts or, phone or something. You can send a message or you receive a automated response. Your server is burning, you should come to the data center. So, for example, these are already ready plugins that you can call, and you don't have to, implement the entire thing yourself by coding or something. You have analysis plugins, discovery, etc. So you can check this. There's a lot of them. So if you want to use this for some specific purpose, make sure that you know that there's plugins existing out there and you can make your life much easier. You can write the plugins as well, I guess. But for now, you don't need to pay so much attention to this. If you want to do that, there is also a possibility, of course. So Logstash, unlike Elasticsearch, this is a different tool. I mean, it's made to work explicitly with logs. So what Logstash does is making the logs meaningful for Elasticsearch to understand. Because if you just drop the logs to to Elasticsearch as they are, that's gonna be it. It's end of the story, and it finishes there. Nothing's gonna happen. It's gonna be just a simple mess. But Logstash creates a structure for Elasticsearch to go through these logs much easier. So now we're talking about logging. We don't focus on monitoring. I'm just mentioning this again. I will repeat it a couple of more times because many people confuse the monitoring with logging. You can tell Logstash the way you want the logs to be, distributed. You want specific structures. You can do that any way you want. You want to divide, I don't know, the system logs from Linux, from, I don't know, logs generated from your, I don't know, SSH. I'm just giving examples. So you want, some specific structures that you want to do, and you want to explicitly monitor your SSH because, I don't know, you're getting a lot of brute force attacks because you use password authentication and you don't use public key infrastructure. Stupid example, I know, but this is just to give you a glimpse what all you can do. You can split logs. Let's say you use Puppet and Chef, like we did with deploying OpenStack Cloud. There is a purpose for Chef and there is a purpose for Puppet. Configuration management and other type of configuration management for lower level things, like deploying a seed node, so you can have a DHCP and DNS inside, so you can install Linux on the machines and RAID controllers, etc. This is what you do with Chef, and Puppet installs the higher level stuff, like provisions the OpenStack services like Glance, Cinder, Keystone, all these things. So in that case, you want to divide the logs, from a from a very, very logical perspective. You don't really want all the logs to be in one place, because system logs, your RAID controller logs, and logs from the Ceph storage cluster are not the same. And you want to split this into two categories. And this is where Logstash shines. Logstash is going to do this for you, of course, if you tell it to do it so, but Logstash can be a bit problematic. I will tell you later why. So Logstash started as an open source tool. It's still an open source tool, but it's been through a lot of hiccups, so to say. So the development wasn't really a smooth ride. And still now it's a matured tool, and there's a lot of plugins for Logstash, as it's a pluggable infrastructure, so there's more than 200 different plugins, and that's what it makes it great for using, because you just have to plug and play. You don't have, not plug and pray, but you just plug something that's gonna work for you, and you have to know what you're doing. So not just, call some random plugins for the sake of doing stuff. As I mentioned before, for the quote from Bruce Lee, just practice one kick 1,000 times, not 1,000 kicks one time. This is the point. Yeah, I put some interesting information here. You can check these links. There are some side projects like Lumberjack or Logstash Forwarder, and now we have beats for that, to alleviate a little bit of that troublesome experience Logstash had through the years. So yeah, there's other log aggregators that are competing with Logstash, but for some reason the Elastic Stack doesn't want to remove Logstash from the from the game, because it's been around for a lot and it's been through a lot, so it's gonna stick around. So that's actually good. I like that. I don't like, when things are changing and it becomes very troublesome for admins, DevOps engineers, scientists, whoever is using this to adapt, to these changes. So it's good that we have, some consistency in this manner. And yes, Logstash is a very crucial component of the Elastic stack. But I will show you some examples. Like the events that you can aggregate through Logstash, they are put in 3 phases. So collection, processing, and dispatching. So now when you collect, it's like in this stage, it's like deciding which data is collected, how it's processed, and then where it's sent to. It's the dispatching stage. So in this case, you can call different plugins for example, input plugins to see what kind of data is going to be collected, filter plugins, what kind of data is going to be processed, or output plugins, what kind of data is going to be dispatched. So there's a lot of plugins here. There's a small link I put here in the codex. So they support codex, the plugins, and they allow you to encode or decode the data to transfer it from, different types of structure like JSON, or you have multi-line or plain data or CSV, etc. So that's priceless. When you start working with, data aggregation and collection, you will understand these things are gonna save a lot of your time. So what are the input plugins? As the name suggests, they can be, different types. Like for example, Beats collector. It has different types of input plugins you can use for Logstash. And yeah, you want to, I don't know, if you use file beats, you want, let's say, file system data collection, just the file system, so you can monitor how your disks are breathing, or you can monitor the smart infrastructure of your RAID cluster, etc. There's a lot of things here. So in general, as I mentioned here in the example, HTTP, input, or TCP, if you use, metric beats and packet beats. So yeah, you can ingest data from a lot of different sources, and this is actually very good. It allows you for a lot of flexibility. Then you have filter plugins, as we saw in the example with Elasticsearch. Like some input filters are like grok, date, mutate, drop, typical, data traversal plugins that you want to go through a database. And there is a link here. I also provided in this small section. You can see like one of the most popular Logstash filter plugins. So as we mentioned, filters are very useful. For example, if you collect network data, you just drop everything from an MPLS network and you get some BGP protocol there, encapsulated VPN, and a total mess. So you really want to have, structure for this. You just want to collect, I don't know, UDP traffic. You just want to collect TCP from certain ports, or, you want to avoid, I don't know, GTP tunneling traffic or layer 2 tunneling protocol, etc. So there's a lot of ways this can be done with filters to manipulate what data is going to be saved and the rest discarded. As I mentioned before, you don't want to collect everything, because more data doesn't mean better solution. So this is one way to do the stuff. Then you can also, let's say, have output plugins, and output plugins are, as we mentioned before, you can create different types of outputs. So let's say you want to, very common way to prepare data for machine learning is to export to CSV, comma separated values. So you can use a plugin that's going to export to CSV, and you can proceed that later to your adjacent system that's going to do the processing. So output plugins are doing this. You can create, standard you can create standard output, and you can, pass that through different multiple output plugins, to create more structured output. So there's the output plugins as well that you can use. Then the codex we mentioned to encode data in different ways. Like data can be usually mass, and the JSON is one very nice structured way to make the encoding. So you can read easily from JSON files, but calling key and values. So it's something that you can use with a default codec, export from the default codec to a JSON codec. So that's something that you can try with Logstash. I'll show you an example for this because we're working with, as we had the case with Terraform and Ansible, you have a lot of JSON standard output there because OpenStack Cloud returns values to the provisioners about infrastructure, and all of this is stored in JSON format. So this is very nice when you want to have everything in one place, but still it's gonna require some brushing in order to make it look nice and work properly. Right. Logstash has its own DSL language, like Terraform did and Ansible. Ansible actually works with YAML, so it's not really a DSL, but Terraform is, or Puppet. So you can, it's not really complicated, so don't worry about that. And we're not gonna go into some very complicated examples. So yeah, we'll just apply some filters and output and codecs and some plugins like this, and you will see how this works. It's nothing complicated. To configure, let's say, input, you can say as an input I'm taking a file. This is very logical, right? And you decide where that file is going to be stored, access.log, or I don't know, syslog or whatever log. So, and yeah, you're deciding that your plugin is going to be input and a file. So you're using a file as an input. Then you want to filter the same as I explained before. So if you want to filter through grok and match, so the grok is going to parse, this key value pair, and it's going to put it to what you need. Like, you see, it's a little bit not very well structured here. You have to pay attention to the braces, because you see outside brace, it's the first one, so you're applying grok to the entire thing. So it means that if you see the tree structure, the grok filter is going to say that we're going to have match date and geological IP location of the data we have from that JSON file or real-time data. So in this case, you're going to see the message that's correlated with a particular timestamp and corresponds to a specific IP address. Okay, so this is like a very classical example. Output, you can use output filters, and usually output filter can be for Elasticsearch to see which hosts are accessing local port 9200 for Elasticsearch, of course. So that's just a very rough example. So doesn't you can try this on your own. There's a lot of different outputs you can decide. Not only for Elasticsearch, you can add an output for maybe Grafana. I haven't tried this. This is new from yesterday as I'm speaking. So that's something I would really like to try. There is an example. I put it before. I think it was in a picture. You can copy paste it. You can try it yourself. So I'm not gonna stick around on that too much. So what kind of problems we have with Logstash? Well, Logstash suffers from some issues regarding its design. So it has inherent problems. It requires a Java environment to run, and usually this is a dependency issue. So installing some of these things can be cumbersome, especially if you're on some specific distributions. You want to use Logstash through, I don't know, ARM architectures or something. I personally haven't tried, and I'm trying to avoid getting to this kind of complications. So in general, yeah, there can be, dependency issues. Then resource shortage, bad configuration. It's very easy to misconfigure it. So yeah, don't expect that things gonna work outside of the box. So yeah, just requires persistence and a little bit of a conservative approach. You start simple and baby steps. You can upgrade as you go. Right, so I put some good practices here that you can use to, avoid problems with Logstash. And one of the best ways is to use Kafka, you know, or Redis or some sort of buffer. And this is, you know, standard way of using the whole thing. We're not gonna do this. It's just gonna make things more complicated for you, but this is the way things are done. So yes, you need to build persistent. There's persistent queues that you need to, you know, enable. They're disabled by default. So yeah, you need at least SSD disk, you know, to cache some of these things in a you know, more better way. If you use a slow disk, you know, you don't know what can happen. You know, skipped, you know, queues, etc. So there's a lot of things that can transpire there, and we can't really know what's happening. So you can't do logging and monitoring of the actual logging and monitoring infrastructure. I mean, you can do that, but that's an expensive practice. So as I mentioned, the best thing is is to keep things simple and test as you go. So just go one by one, see what is gonna happen. Because if you just try to do a lot of things at one time, something's gonna go wrong at some point, and it's gonna be very difficult to figure out where. And then you will send me a message or someone else to ask for some help, and it's gonna be very, very difficult to help. But if you take things step by step, it's more likely that you will know what is gonna fail. So if you take a next step and that fails, you know what to avoid. So this is the way of thinking you need to apply in this case, because as I mentioned, Logstash is not something that's gonna just work in plug and play manner. You can monitor Logstash, as I said, and I don't know if you can use Prometheus for this. I haven't tried. There's other ways. You can use most likely beats to export some data from the Logstash itself. But yes, this is a way things can be done. And you can represent this with Kibana and configure it accordingly. So yeah, so it's something that's good practice to use the monitoring API to see what Logstash is gonna do. So it's not something unusual. Now, shortly about Kibana. Yes, Kibana is a dashboard, and more than just a dashboard, because it has adds a very nice layer on top of the Elasticsearch and Logstash, which you can use for a more interactive approach of log aggregation and passing the monitoring features, and also representing the outputs that you use with your output plugins. So it's open source, and I showed how it can be installed. It's very simple. I provided a couple of additional links here if you want to use on Windows or Mac or a different operating system. There is a nice tutorial on the link here. So yes, you can check the documentation as well. They have a lot of nice features. So like I said before, Kibana is very good if you want to have things, you know, in one place, and this is something that that's done like very seamlessly. It uses a language called KQL. It's a Kibana querying language. So it's not the same like the Elasticsearch and Logstash, but you need to, I will show you later. It's something that's not really something super complicated, but yeah, it gives you, you know, for example, you want to represent specific stuff in specific graph, or, you know, relational way. So there is a lot of interesting details here. And it looks very nice, to be honest. So yeah, when you want to search through for some specific thing, you can just query it, and you can filter it. And yeah, for this search types, there is a very detailed explanation in this link. You can check this. It's I think it's gonna help you a lot if you want to learn very good details about Kibana itself. So this is a small cheat sheet I provided for you. It's text. You can, you know, use different wildcards, prefixes, and stuff. So please feel free to refer to this slide if you want to go through queries in Kibana. Yeah, this is how it looks like. It has an autocomplete feature, and I mean, we showed the Kibana before, but this is just a small glimpse, because Kibana has lots of tools around there, so you can get lost pretty much easily. You know, the autocomplete feature, it suggests, you know, something like you type co and you're gonna get, you know, suggestion that you want country name, GeoIP, country code, you know, whatever you want to filter through. So when you press it, it's very nice. It's very neat, you know, it's very intuitive and it works excellent. For filtering, you can add filters, as you see here. If you click on this little link and the plus button, you can add a specific filter for a specific value. So you just add the key, response, or I don't know, the operator can be is, and, whatever you define, and value 200. So you can filter through specific things through the database. The visualizations are something that's you can make on your own. There is a link here how to do this, but out of the box, Kibana has a lot of nice visualizations. You don't have to pay too much attention to this out of the box. It works great. So you can take a look in the link. They have a lot of nice ways how you can build your own custom charts, you know, graphs and things like that. So if you want to add a visualization, you can go to a new visualization. It's very difficult to show it like this because it's, you know, a slide, so I can't, you know, interactively show you all this, but we'll get to that. And you can put a lot of different stuff like gauges, you know, bars, and you know, this is fancy. This is what people like on presentations. When you go and do some presentation and you show a code or something, you're boring, you know, nobody wants to listen to you. But when you pull out, you know, your browser and you just type your Kibana IP address and things come up like this, everybody's gonna look and it's gonna be, wow, it's awesome things, you know, you did a lot of work there, great stuff. And it's not only about that, but also about yourself. You have, you know, a visual representation of how things are done. It's much easier to understand if something's going wrong, if you see some peak somewhere. This is how we work. Humans can't read through a lot of cluttered text and, you know, code and stuff so efficiently as we can through, you know, pictures and using our eyes to detect, you know, inconsistencies within a picture or something similar. So visualizations in Kibana are categorized into 5 types of visualizations. You have basic charts like area, heat maps, horizontal bars, lines, pies, or vertical bars. Then you have data visualizations, which is like a date table, gauges, goals, or metrics. You have maps like coordinate maps, regional maps. You have time series, like something I would like to try if it works with Prometheus and InfluxDB. Then you have others, and you can create your own. So you can create custom visualizations, and this is most likely the common thing. Things are done because you don't really sometimes find what you can get there out of the box. You need to create your own, but that's not a problem. It's not complicated to do. There is a small table here, not very small, but still you can see like some visualization examples. And yeah, like for example, area charts is for visualizing time series data and for splitting lines on fields, and it's used, you know, something that's in a timed manner. So that's classical way of doing things. Or line chart, a simple way to show time series for splitting lines to show anomalies like, you know, CPU usage over time, etc. So that's, you know, just a simple example here. Another example, for example, you have coordinate maps, regional maps, geographical origin of web server requests, like where your requests are coming from. So you can plot that. Like I have a lot of requests on my web applications from US, etc. And you can use that information, you know, as an output to tell your infrastructure provisioners or automation tools to redeploy the same infrastructure in a different cloud region, right? And to remove this one for the time being. So when you get new information about geographical origin of requests, you can move it back there, etc. So that's just one way you can do things. There's endless, you know, you just have to use your imagination, endless ways. Dashboards, as I said, they are very dynamic. I think I have some example there. We all know what dashboards are. So they are very nice to pinpoint specific problems. If you have like a lot of HTTP request, it can be easily correlated with high CPU usage or high HTTP usage, etc. It's logical. So if you see these three happening, then you know that something's like it should be, like, or there is a lot of traffic, etc. But if you see just high CPU usage without too many HTTP requests on the web server, then there is something happening in the background. You have to check the VM or maybe the physical server or something else. Just a rough example. Kibana has pages, and this is something introduced as a new feature. So these pages, you know, they are part of they were part of a formerly known as XPack, but now you can, you know, use Canvas. Canvas is an advanced visualization tool. You can design, visualize logs in a very, very creative way. It looks beautiful, you know. So if you install Kibana, you will see what I'm talking about. If you go to this portion, then you have, you know, this is something I will try to demonstrate for you, like infrastructure visualization. So this is very, very useful. You can monitor the hosts, the containers running, etc. So you don't really need anything beyond that. That's more or less everything you need. Last but not least, Kibana has option to pass indexes for Elasticsearch. So this is something stored in a special index called .kibana, and it's usually used for debugging or, you know, understanding if something goes wrong. So you can, you know, get a glimpse of what's happening within the monitoring system. Yeah, there's the index contains some documents like this. They have their own fields like patterns, searches, visualizations, and dashboards. So these are, you know, some indexes that you can save. Yeah, so that's about Kibana. It's nothing, you know, complicated. You will check it yourself. It's a very, very fancy tool for representing things visually. And now we're gonna go with beats a little bit. This is the last piece of the puzzle. It's a newly implemented feature of the Elastic Stack. So beats is a collection of log shippers. They have they have different types of shippers for different purposes, as I mentioned before, and they can be installed as agents on different servers in your environment to collect data and to send to the Elastic Stack. So, for example, PacketBeat, as I said from before, you can monitor your network, and you can send to the Elasticsearch, or you can collect, I don't know, Windows event logs if you work with Windows, and you can send it for Logstash aggregation and then Elasticsearch. So there's a lot of different beats, and they're coming more and more. So as we speak, there's gonna be more types of filters and plugins you can apply for this. For now, I will represent a couple of these. You have file beat, packet beat, metric beat, winlog beat, Audi beat, function beat. So all of these, they have their own purpose. I put links for them here. You can check examples how you can use this and, you know, install. It's not just a documentation in the Elasticsearch website, but it's a, you know, tutorial how you can use all of this. We can't go through all of that, of course. It would take a lot of time. So I ask you to try all of this if you can, if you have the time. It's very, very neat, very nice. So I will make you an example with perhaps metric beat and packet beat, so we can collect some information from the VMs and, you know, the network, like web server traffic, etc. So yeah, like I'm not sure I can do the file beat thing. I'll try with this as well, because we have a MySQL database, and I will try to give you an example for this. You can also deploy these things as a Docker container. So if you're running a containerized environment using Kubernetes or something else, you can deploy the beats as a container. So it's gonna work the same way. It doesn't matter. It's a very lightweight tool in general. So to configure beats, you need to understand what you're gonna collect. So if you collect metrics, you need to configure this in, let's say, etc metric beat metrics.yaml, and then you're gonna have to supply a specific configuration parameters for this type of configuration, because metrics are the data which is coming from your underlying infrastructure, like CPU usage or the VM's logs. Like if you're gonna collect some logs together with the metrics, so you need to understand first what you're gonna do before you go for installing something like this. Like for example, packet beat. You don't need to really collect everything from the network. You just need to collect, let's say, on port 80 and 443 HTTP traffic, HTTPS, or you want to collect on some specific port like 3306, connections going to your database. If you see some connections coming from place that you haven't configured, it can be considered as, potential attack or something on your database. So something like this, and this is done in a YAML file, so it's very, very, intuitive. I'll show you examples of this. So beats have different modules as all the components from before. So these modules will help you start out, with pre-configured settings, and you can use, let's say, for file beat, you have Apache modules, Cisco modules, MongoDB, different stuff, Kafka, etc. For metric beat, you have, AWS. This is like very useful. You have Ceph, you have Docker, like there's a lot of stuff. So you can check these things. It's endless list, and it's growing, of course. You can make your own. Like I have some modules that I'm using for 5G networks. So this is something that's very, very useful to understand, that you can plug it and it's gonna make your life much easier and your work shorter. Another example is a configuration something like this. So this is a Puppet log. I think it looks familiar because the Puppet Labs keeps log. The Puppet keeps log in the Puppet Labs directory in a JSON format, and you can parse this and you can pass it to Elasticsearch. So that's a way how you can track Puppet server logs. Some of the best practices for configuration. Every beat, it contains its unique configuration, so you don't need to mix this, because sometimes you get confused that metric beat and packet beat, they need to be done in the same way because of whatever. No, that's not true. You need to do it separately and to think about what you need to achieve with these two types of collectors. So metric is gonna collect, as I said before, your CPU and, let's say, HTTP traffic. So you need to understand what you want to expect from this collection. It's more or less like creating a logical pattern for collecting the stuff, not just, random association of, I don't know, temperature in your data center together with how much SSL traffic is going through your infrastructure, because you assume that SSL requires or VPN or something. It requires encryption power, and that's why the temperature in your data center grows because of that. It doesn't work really like that. So don't confuse these two things as such, and you have to think separately for each. For example, some beats, as file beats, they have like configuration files like this, as it's indicated, and it's good to split this, in separate structures. You don't want to mess one thing with another, then you're gonna get completely confused. You're not gonna know what's going on. So YAML files are, extremely sensitive. It says do not use tabs when you're indenting your lines. Doesn't really matter if you use tabs or spaces. Just be careful about indentation. That's the only thing. So if you miss some indentation somewhere, you can use some linting tool to help you with the indentation of YAML. But then again, sometimes it can be hard to pinpoint the exact problem within the file, and it can originate from just additional space somewhere in between the lines. And you can use a text editor. Sometimes I use Sublime, sometimes I use Vim when I'm lazy. it doesn't really matter. Use the text editor that you like, and it supports some sort of syntax highlighting and some indentation help that you're gonna get when you write YAML files. It's gonna make your life easier. Don't use dash characters. That's something I mentioned also with the Terraform and Ansible declarations, because dash is an operator for some things, so it can be easily confused by the parser and whatever program is going in the background, like Python with Ansible, that you're gonna use some operator. So you can use underscore instead of dash. So just make sure you don't use dash too much. So at the end, I would like to say a couple of words before we conclude this. Is that where would you like to apply something like log collection analytics? Not only data processing and science, but it's actually where you want to make something work in your advantage. Like, for example, you have a big infrastructure and you want some sort of alerting, and you want to have comprehensive way to handle problems and to actually avoid problems. So you should understand the limits and also the potential these tools have for your use case, because Elasticsearch has a lot of different use cases. I mean, the entire Elastic stack. So you don't have to stick to the general paradigm of the things, but just understand what you need for your use case. If you're doing cloud operations, just make sure you're going to use the right things that you need. If you do some development of software or whatever it is, there is another way you can do the things for that to monitor stuff. If you work in a factory, let's say, and a nuclear power station, you want to monitor the reactor cores, how much boron gets into the nuclear chain, to stop it from escalating. Just an example. They have some different monitoring tools for that, different security systems called SCADA, but you're not going to use Elasticsearch for it. But you can, of course, absolutely you can. It doesn't matter. You can use it for self-driving cars. That's another use case I know. This is called vehicular network slice in 5G. So for self-driving cars, there's a lot of information going there. Cars exchange information in a mesh network structure. And there's a lot of things you can collect there, like for security purposes, for incidents avoiding, low latency communication things, stuff like this. That's gonna show how much you can achieve with the actual slice. So just first understand what you need this for, and then you have to focus on this and don't make it too complicated. So just use the exact things that you need and try to keep it as simple as possible, because it doesn't matter if you make something complex to show off your skills, that you know how to configure the Elastic stack. It's just gonna make a nightmare of your life, and it's not gonna be productive. Just keep it simple and do the exact thing that you need. I think this is it for today. Thank you again for the attention. It's been a little bit of a longer video, but we have to introduce all these things. So I'll keep you updated. So stay put. There will be another video for elucidating all of this through examples. I'm a bit tired lately. I have a lot of work to do, so I'll try to keep it up for you as best as it's possible for our use case, to understand how we can use this for cloud environments and in general operations within clouds, either configuration management, containers, DevOps, etc. So thank you for watching and see you next time.